Today we are going to go over extreme values on an interval and the mean value theorem and Rolle theorem. So the extreme value theorem, if f is continuous on the closed interval a to b, and in this case f will have both a minimum value and maximum value. Just keep in mind it has to be a closed interval. So how do we find the absolute max or absolute min? We first need to find the critical points. So compute the critical point. There are two types of critical points. One is the first derivative equals 0, or the first derivative doesn't exist. Keep in mind there are two types of critical point. And also, if the function is not defined at that point, we don't call that point a critical point. Then we make a table and compare with all the values with the boundaries. The maximum one give you the absolute max, and the minimum value give you absolute minimum. So let's have a look at example 1. So given function f(x) in the closed interval 0 to 3. So first we check f(x) is continuous on the closed interval. Next, we calculate the derivative. We set equal to 0. And these are the critical points. Because -2 is not inside the interval, so we only keep 2. So these 2 points, 0, 3, are the endpoints, and 2 is the critical point. We calculate the y values, and the maximum value, 16. So at x equals 2, we have the absolute max, and at x equals 0, we have absolute minimum, 0. For example, 3. f(x) equals this function from -8 to 27. As we know, f(x) is continuous. First is continuous. Next, we calculate the derivative. When we calculate the derivative, we set a derivative equals 0. There's no x value. Give f prime equals 0. However, when x equals 0, the derivative doesn't exist. This is also a critical point. So we combine the critical point 0 and the two endpoints, the y value. So we get max and min value. This is what we call the absolute max and the absolute minimum. Same thing for absolute value. How do we get the split point or the break point? We just set x minus 4 equals 0. So at equals 4, the function were defined differently. So at x equals 4, the derivative doesn't exist because it's a V shape. So this is a corner. Now we combine the endpoints and the critical point. We compare the y value. So we get absolute max and absolute minimum. So most of the time we see at x equals 10, the absolute max is 6. And at x equals 4, the absolute min is 0. Next, we are going to go over the mean value theorem and the Rolle theorem. So mean value theorem, if function f is continuous on the closed interval a to b and differentiable on the open interval a to b. So in this case, there will be a number c where the derivative at c equals fb minus fa over b minus a, and a and b are the endpoints. So if you look at this picture here, so from a to b, fb minus fa over b minus a basically is the slope of the secant line. So this tells us if the function is continuous and differentiable in that interval, there will be a point, the slope at that point is equal to the slope of the secant line. Also, we have some very important names. So f prime at c, which we call the instantaneous rate of change at point c. And the right side, fb minus fa over b minus a, which we call the average rate of change from a to b. So how do we apply mean value theorem? First, we have to check if the conditions are satisfied. That means we have to check if it's continuous and differentiable. So given example 1, f(x) equals sine of x, 0 to pi. As we know, sine of x is continuous and differentiable. everywhere, value theorem does apply. So we take the derivative. Next, we set the derivative equals fb minus fa. In this case, a equals 0, b equals pi. We plug in, we solve for c equals pi over 2. Same thing, quadratic equation, continuous and differentiable everywhere. So mean value theorem applies. So you do have to check the conditions. Then we take the derivative, set equal to fc prime. So c equals 1/2. Example 3, absolute value function. As we know, x minus 3, when x equals 3, the function is not differentiable because it's a V shape. So in this case, we cannot apply MVT because 3 is right in the range. Rolle theorem. Rolle theorem is a special case of mean value theorem because in this case, if f is continuous in the closed interval and differentiable on the open interval, if the two ends fa equals fb, there will be at least one point c where the derivative of c equals 0. So this is a very special case. If fa equals fb, there will be at least one point the slope equals 0. So make sure before you apply Rolle theorem, check the conditions. Okay, let's look at example 9. So given fx, -1 to 2, so first we know it's continuous and differentiable everywhere. And then the two endpoints both equals -4. So equal, continuous, differentiable, we could apply Rolle theorem. That means there will be a point the derivative equals 0. So we take the derivative set equal to 0, c equals plus minus 1. And make sure this open interval a to b, there will be a c value. So c will only keep positive 1. Number 11, because this function fx equals x squared over 1 minus x squared. And we can see at x equals plus minus 1, the function is not continuous. So because it's not defined, so it's not continuous, we cannot use the Rolle theorem.